Good day, everyone. We are Group 10 and we are going to report about Chapter 10, Experimental Design. I'm going to read the objectives. By the end of this chapter, you should be able to define experimental research and describe when to use it and how it developed. Identify the key characteristics of experiments. State the types of experimental designs. Recognize potential ethical issues in experimental research. Describe the steps in conducting an experiment. And then lastly, evaluate the quality of an experimental study. To give you an idea already, an experimental design is a traditional approach to conducting quantitative research. And I will give the virtual floor to my co-reporter.
Pleasant day, classmates. I am Trisha Macado and I am going to discuss the subtopic, What is an experiment, when should you use it, and how did it develop? Initially, in an experiment, you test an idea to determine whether it influences an outcome or dependent variable. And then to further elaborate on that idea, it is a procedure carried out to test a hypothesis or determine the causal relationship between variables. When they use an experiment, so we use an experiment when we want to establish a cause and effect relationship between variables. This means that we control all factors that could influence the outcome except for the independent variable. Experiments are particularly useful when you have two or more groups to compare, as they allow for controlled conditions and systematic comparison. For example, if you want to compare the effectiveness of two teaching methods on student performance, you would use an experiment to ensure that the only difference between groups is the method of instruction. When did experiments develop? Experimental research has its roots in the late 19th and early 20th centuries, particularly in psychology. Early pioneers like Schuyler and McCall laid the foundation for experimental methods, with McCall introducing the concept of randomly assigning individuals to groups in 1916. By the mid-20th century, statisticians like Fisher had advanced the statistical techniques necessary for experimental research. Campbell and Stanley's work in 1963 identified major types of experimental designs, which are still widely used today. Subsequent developments by Cook and Campbell in 1979 and refinements by Shadish, Cook, and Campbell in 2002 further enhanced our understanding of experimental design and validity of tests. Since the 1980s, experiments have become more sophisticated due to the advancements in technology and statistical procedures. Researchers now utilize complex experimental designs with multiple independent and dependent variables, compare more than two groups, and study various units of analysis. Procedural refinements and resources like how-to books have helped researchers strengthen the experimental studies and design more sensitive experiments. We can gladly say that experiments are a powerful tool for establishing cause and effect relationships between variables, and their development over time has been marked by advancements in both methodology and statistical techniques.
Now let's proceed to the key characteristics of experiments. But before we consider how to conduct an experiment, it is better and helpful to understand in depth the several key ideas central to experimental research. And these ideas are random assignment, control over extraneous variables, manipulation of the treatment conditions, outcome measures, group comparison, and threats to validity. Now, to further understand this, we will be using an educational example to illustrate key ideas central to experimental research. Initially, we want to help teenagers to stop smoking, and as researchers, we will be using high school as an example to explain the key characteristics of experiments. Now, here's the drill. When students get caught smoking at school, they have to take a special class about the dangers of smoking. We then show pictures of damaged lungs and ask students to write about their smoking experiences. And this will be called civics smoking experiment in this particular school. Now to talk about the random assignment, it is when you put students into groups to study them, and the best way to achieve this is to randomly assign them, meaning you don't just pick who goes where. And this idea helps us make sure that each group is similar so the results are fair. And it is called equating the groups. In our example, students caught smoking would be randomly put into different civics classes. Take note, this is different from randomly selecting individuals from a larger group, which is important for making sure that the results apply to a bigger population. So, in practical solutions, like this experiment, it is often easier to assign individuals based on who is available rather than just randomly selecting them. But it is important to know that random assignment is the standard for experiments like this. The next is control over extraneous variables. Now, when we randomly assign students, we are trying to control other factors that might influence the results, like who participates or how we run the study. Now, there are certain factors that could give us different explanation for the findings than what we expect, and we call this extraneous factors. Hence, every experiment has some random mistakes, but we try to examine other influence as much as we can. But remember, random assignment is a choice we make before the study starts. But there are other ways to control factors during the study, like doing pre-test and post-test, covariates, matching of participants, homogeneous samples, and blocking variables. Now let's talk about the pre-test and post-test. Now to make sure that the group are similar, we might use pre-tests. For example, the study about attitudes towards smoking, we could measure the attitudes before the treatment. That's just how simple pre-tests can be done. However, pre-tests can have both good and bad sides, as they take time and can affect how participants respond later on. On the other hand, post-test is when we measure the attitudes after the after the treatment, like the special class taken by particular students. Thus, in our case, we check students' attitudes after the treatment, and comparing both pre-test and post-test, determining the results like if the treatment really made a big difference in students' attitudes towards smoking. Now let's proceed to covariate. It is when we often check if something we do affects the results. So we use a method called covariance in order to make sure that the pretest does not mess up with the results. Covariance helps us compare two things accurately by removing any factor affecting the results. For example, if we are studying smoking habits of the students, we might also look at whether the parents are smokers. Now, by using this method, we can really see the treatment affects smoking rates without other factors getting in the way. That's how covariates work. Moreover, matching of participants is an experiment means making sure of the groups are similar in certain ways before starting. For example, if we are studying smoking habits in high school students, we might make sure that both groups have an equal number of boys and girls. In this way, our prior knowledge, for other example, the boys may smoke more often than girls, so controls for the potential influence of gender on frequency of smoking. So, we match up the boys with the girls in both groups before and after starting the experiment. While homogeneous samples make sure that the groups in an experiment are similar, like we sometimes would choose individuals who are likely in many ways. For example, if we are studying smoking habits in civics classes, we might select students who have similar grades, genders, and backgrounds for both classes. Through this, We control things like grade level that could affect the results. Thus, we try to make the group as similar as possible before starting the experiment. Furthermore, blocking variables is a method where researchers divide participants into groups based on something specific. Before starting the experiment, for example, we might divide students by grade level, then we randomly assign students from each group level to different groups. This method helps ensure that each group has a mix of participants from different grades or grade level. So, these are the control procedures we may use before and during the experiment.
Now, let's explore the various types of experimental designs commonly used in educational research. These designs are like different tools in a researcher's toolbox, each with its own purpose and strengths. First up, we have between group designs. These include true experiments. True experiments can have a pre-test and post-test, or just a post-test setup only. Second one is quasi-experiments. Similar to true experiments, these also have pre- and post-test or post-test setups only, but with some difference. Third one is factorial designs. These are a bit more complex, involving multiple factors or variables. And then next, within group or individual designs. These are time series experiments. Think of this as before and after studies, either interrupted or equivalent depending on how the study is structured. Second, repeated measures experiments. Here, the same individuals are measured multiple times. Then third one is single subject experiments. This focus on one individual's response to different conditions or treatments. It's important to recognize these designs and understand their key features. So this helps us to choose the design for our study or helps us to evaluate someone else's research. Let us take a look at Table 10.1, which outlines a basic set of criteria for differentiating among these types of experimental designs. We'll keep these criteria in mind as we go through each design, focusing on random assignment of participants. How are people assigned to different groups? Number of groups or individuals being compared. Are we looking at 2 groups, 3, or more? Number of interventions. How many different things is the researcher doing to see the effects? So by the end of this discussion, you'll have a clear picture of the tools available in experimental designs, whether you're planning your own study or evaluating someone else's. Understanding these designs will be crucial. Let's dive in. So let's proceed. Between group designs. In educational research, one common approach is to compare different groups. The most rigorous type is called a true experiment. Here, researchers randomly assign participants to different groups. One group gets the treatment and the other doesn't. Afterward, they compare the average scores. If there's a pre-test, they compare scores before and after the treatment. Sometimes, researchers can randomly assign people to groups. They have to use existing groups, like school classes. This is called a quasi-experiment. It introduces more threats to validity because the groups aren't randomly assigned. Third is factorial designs. When researchers want to see how multiple factors affect an outcome, they use factorial designs. This lets them study the effects of different variables together. For example, they might look at how both a health lecture and depression levels influence smoking rates among teens. This design needs more participants and can be complex to interpret. In factorial design, the researcher first chooses a research question with two or more independent variables and one dependent variable. Second, sets up levels for each independent variable, and then creates groups based on these levels. Fourth is collects data and compares the results to see if there are differences. Fifth, uses statistical methods like ANOVA to analyze the data. Then lastly, graphs the results to show any patterns or interactions between variables. These designs help researchers understand how different factors combine to affect outcomes, like smoking rates. Graphs can show how variables like depression and type of instruction might influence behavior. Okay, let's proceed with in-group or individual designs. In some experiments, we can only study one group or individual, so we use within-group or individual designs. These include, first, time series. So it is when researchers study one group over time. It might take multiple measures before and after an intervention. This design helps understand change in a system, like a school district. And also, it is a labor-intensive because it collects lots of data. In time series, there are two types. Interrupted time series, which means it measures before and after an intervention. Then the second type is equivalent time series. Alternates between treatment and post-test measures. Following time series is repeated measures. It involves one group getting different treatments, with each person acting as their own control. We compare performance under different treatments. So repeated measures helps avoid threats to validity related to comparing different groups. Following repeated measures is single subject designs. It is when the researchers study one person's behavior over time. It involves a stable baseline before intervention and observations after. And then it plots behavior changes to see if the intervention worked. So for examples here is the A-B design, which is letter A, baseline observation, and letter B, intervention. So they use this to see if it changed. And then multiple baseline design. These treatments at different times for each person to avoid spreading effects. And then alternating treatments. So it compares effects of different treatments on outcome. Key points here are these designs help when we can only study one group or person. They control for many threats to validity. And they can be complex, but they give detailed insights into individual behavior. So these designs let researchers carefully study how treatments affect behavior in real-world settings, even when only one group or person is available for study.
And now we are going to talk about potential ethical issues in experimental research. In experimental research, ethical considerations are paramount. First on our list is withholding treatments from control groups can raise ethical concerns, particularly if individuals are disadvantaged. Next, strategies to address this include providing treatments after the experiment or offering them to control groups post-study. Next, ethical debates also surround randomized assignments, balancing the need for understanding causality with potential disadvantages for individuals. Another is federal guidelines exist to justify random experiments requiring addressing important needs, providing the best course of action and respecting participants' rights. Another is ethical considerations include discontinuing experiments if one treatment condition significantly outperforms others. And lastly, experiment methods should ensure the best answers to problems and consider the stakes involved. Overall, ethical issues in experimental research require a delicate balance between a scientific rigor and then the protection of rights and welfare.
Here are the steps in conducting experimental research. Now, when conducting an experiment, it is important to follow certain steps. First, decide on the experiment. First, decide if an experiment is the best way to study your research problem. Experiments are great for studying cause and effect relationships. Second, form hypotheses. Make predictions about what you think will happen in your experiment. These predictions are called hypotheses. Make sure your hypotheses have variables that you can measure. Third is select participants. Decide who will take part in your experiment. You may choose volunteers or groups that are easy to study. Fourth is choose the treatment. Decide what intervention or treatment you'll use in your experiment. Make sure it is something that can make a difference and is practical to implement. Fifth is choose a design. Now decide on the type of experimental design you'll choose. This depends on your research question and the resources available. Six is conduct the experiment. Carry out the experiment according to your plan. This involves administering tests or treatments and making sure everything is done properly. Seventh is analyze the data. Look at the results of your experiment and analyze them. This involves coding the data, comparing groups, and using statistical tests to see if there are any significant differences. Now write a report. That's number 8. Finally, write a report about your experiment. Include details about the participants, design, treatment, and results. Use standard research terms and be objective in your report. Now, by following these steps, you can conduct a successful experiment and draw meaningful conclusions with your research.
How do you evaluate experimental research? So the key characteristics and the procedures form a basis for evaluating an experimental study. The following list, adapted from Basel in 1994, presents criteria useful in this evaluation. For a good experiment, here are some criteria. First, the experiment has a powerful intervention. The second one, the treatment groups are few in number. Third, participants will gain from the intervention. The fourth, the researcher derives the number of participants per group in some systematic way. Fifth, an adequate number of participants were used in the study. Sixth, the researcher uses measures and observations that are valid, reliable, and sensitive. Seventh, the researcher controls for extraneous factors that might influence the outcome. And then last criteria, the researcher addresses threats to internal and external validity.
Now these are the key ideas in the chapter. Experimental research involves testing an idea or practice to see how it affects an outcome. It's been around since the early 20th century and has evolved with better tools and methods. Key characteristics of experimental research include random assignment of participants, controlling for other factors, and physically changing treatments to see their effects. There are different types of experimental designs, like true experiments with random assignment, quasi-experiments without it, and factorial designs testing multiple variables. Now, ethical issues and experiments including deciding who gets treatment and when to end the study. Now, steps in conducting an experiment include forming hypotheses, selecting participants, administering treatments, and analyzing results. Now, a good experiment has a strong intervention, few groups and valid reliable measures. Tips for researchers includes using random assignment, controlling for other factors, and clearly explaining the design and outcomes in the reports. When reviewing experimental studies, understand the researchers may study individuals, groups, or whole organizations. Note that some studies may not randomly assign participants to groups called quasi-experiments, which are still valuable but less rigorous. Recognize that all experiments involve exchanging a variable. So ask yourself what variable the researcher is manipulating. Next is look for the type of experimental design used in the study, using resources like Table 10.1 for guidance. Now, for more detailed discussions and additional resources on experimental designs and validity issues, you can refer to books and papers by authors like Campbell, Cook, and Shadish, as well as resources on power analysis and statistical procedures.